Welcome to this advanced Kubernetes tutorial on custom resource definitions. In this video, we'll explore how to extend the Kubernetes API by creating your own custom resources. This powerful feature allows you to define domain-specific objects that integrate seamlessly with Kubernetes, giving you the flexibility to manage any type of workload or application using native Kubernetes tooling. A custom resource definition, or CRD, allows you to extend the Kubernetes API with your own custom objects. Think of it as a way to teach Kubernetes about new types of resources beyond the built-in ones. With CRDs, you can define new resource types that suit your specific needs. These custom resources are stored in etcetera, just like native Kubernetes objects. The beauty of CRDs is that once defined, you can manage your custom resources using kubectl and all the familiar Kubernetes tools, making them first-class citizens in your cluster. Let's compare native resources with custom resources. Native resources are the built-in objects that come with Kubernetes, such as pods, services, and deployments. These have a predefined structure and provide core functionality out of the box. On the other hand, custom resources are user-defined extensions that you create yourself. They allow you to define your own schema and validation rules, enabling you to build domain-specific objects tailored to your unique requirements. This flexibility makes CRDs incredibly powerful for specialized use cases. Now let's look at the basic structure of a custom resource definition. Every CRD starts with the API version, apextensions.k8s.io/v1, and the kind custom resource definition. In the metadata section, you specify the name, which must follow a specific format, the plural name followed by your API group. The spec section contains the group name, which is used in the REST API path, the versions array that lists all supported versions, the scope, which can be either namespaced or cluster-wide, and the names section where you define how your resource will be referenced, including the kind, plural, and singular forms. Let's break down the key components of a CRD. The group is your API group used for organizing related resources under a common namespace. The version defines which API version you're using, such as V1, V1 Alpha 1, or V1 Beta 1, allowing you to evolve your API over time. The scope determines whether your custom resource is namespaced, meaning it exists within a specific namespace, or cluster-wide, meaning it's available across the entire cluster. Finally, the names component includes the kind, which is the camel case name used in resource manifests, along with plural, singular, and short names for convenient CLI usage. Here's a complete example showing all the pieces together. In the spec section, we define our group as example.com. The versions array specifies that V1 is both served and used for storage. The scope is set to namespaced, meaning these resources will live within Kubernetes namespaces. In the names section, we define databases as the plural form, database as the singular form, database as the kind used in YAML manifests, and DB as a convenient short name. This configuration creates a fully functional CRD that Kubernetes can understand and manage. Schema validation is crucial for ensuring data integrity in your custom resources. Using the OpenAPI v3 schema, you can define exactly what fields your custom resource should have and what type of data each field accepts. In this example, we define a schema where the spec section contains two properties: replicas, which must be an integer with a minimum value of 1, and version, which must be a string. This validation happens automatically when someone tries to create or update your custom resource, preventing invalid data from being stored in your cluster. Once your CRD is defined and applied to the cluster, you can start creating instances of your custom resource. This example shows a database custom resource. Notice how the API version matches the group and version we defined earlier. Example.com/v1, the kind is database, exactly as we specified in our CRD. In the spec section, we provide the actual configuration: 3 replicas, version 14.2, and a storage size of 100 gigabytes. This resource can now be managed, just like any native Kubernetes object. Working with CRDs involves a few simple kubectl commands. First, you create the CRD itself by running kubectl apply with your CRD definition YAML file. This registers the new resource type with Kubernetes. Next, you create instances of your custom resource by applying your custom resource YAML files. Once created, you can list all instances using kubectl get databases, which works just like getting pods or deployments. Finally, you can view detailed information about any specific resource using kubectl describe database, followed by the resource name. These familiar commands make managing custom resources intuitive and consistent with the rest of Kubernetes. Let's recap the key points about custom resource definitions. First, CRDs extend the Kubernetes API by allowing you to create custom objects tailored to your specific needs. Second, you can define a schema with OpenAPI v3 validation to ensure data integrity and proper structure. Third, once defined, custom resources can be managed using kubectl commands just like native Kubernetes resources. Fourth, combining CRDs with custom controllers enables powerful automation and reconciliation logic. Finally, CRDs enable domain-specific abstractions, allowing you to represent complex application concepts as Kubernetes native objects. This makes Kubernetes incredibly extensible and adaptable to virtually any use case.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.